Hi everybody, so today is Wednesday, May 11th. We are going to be doing the Unit 2 test review through Zaption. Your homework for tonight will be to study for the test. Alright, so the first question is to assign the following descriptions to the correct term and choose from the following. A, pure substance, B, mixture, C, compound, and D, element. So it contains two or more elements combined in a fixed proportion, a physical blend of two or more substances, matter that is uniform in composition, and the simplest form of matter that has unique properties and is comprised of one single type of atom. So letter A is a compound, letter B is a mixture, letter C is a pure substance, and letter D is an element. Provide examples for each of the following. Examples of a pure substance include gold, silver, salt, and others. Examples of a mixture include salt water, chili, tap water, and many others. Examples of a compound include salt, pure water, and many others. Examples of an element include gold, silver, anything you can find on the periodic table. And that's a review from back in the very beginning. For all of the following, answer true or false. Letter A, all homogeneous mixtures are solutions. Letter B, mixtures whose components are unevenly distributed are called homogeneous mixtures. Letter C, salty seawater is an example of a homogeneous mixture. D, homogeneous mixtures can only be created if two of the same phases are mixed. And letter E, a variety of techniques are available for separating both homogeneous and heterogeneous mixtures. Letter A is true, B is false, C is false, D is false, and E is true. So look at the following image and assign the term of solute or solvent to items A and B in the image below. Good. Letter A is the solute. It's what's being dissolved. And letter B is the solvent. It's what's doing the dissolving. What is the solvent in seawater, soda, and lemonade? If you are discussing the amount of solute in a solution, you are referring to the solutions, and then assign the following descriptions to the correct term. Water is the solvent in seawater, soda, and lemonade. That's what does the dissolving. Anytime you're discussing the amount of solute in a solution, you're referring to the solution's concentration. And then for the matching, 1 is D, 2 is E, 3 is B, 4 is C, and 5 is A. So check to make sure that's what you had. In your own words, describe collision theory and how it relates to the process of dissolution. So basically what happens with collision theory and in the process of dissolution is that first molecules of solvent attack molecules of solute. Random molecular motion results in collisions between solvent and solute molecules, and those collisions cause the solute to break down and mix with the solvent. Alright, so take a look at these statements right here and mark an X next to each technique which might increase the dissolution rate of most solids in liquids according to collision theory. Alright, so the ones that will increase the dissolution rate of most solids in liquids according to collision theory would be if you increase the temperature of the solvent, that increases the speed of the molecules. If you If you were to grind the solid into smaller pieces, that would work as well. If you were to stir the solution more quickly, remember, grinding the solid into smaller pieces, that increases the surface area. So stirring the solution more quickly, that's going to cause more collisions. Or if you add more liquid solvent, then there's more solvent available to dissolve the solid. Alright, so moving on to our review of molarity and mole fraction. So molarity is measured by the number of blank in one blank of solution. And then you want to write the general equation for molarity. Choose the correct term to finish the statement. So molarity and mole fraction are a measure of solution, and then pick one of the two. Molarity is most often used when a solute is a blank and the solvent is a liquid. So molarity is a measure of the number of moles of solute in 1 liter of solution. And the general equation is molarity is equal to moles of solute over liters of solution. And the tricky thing here is a lot of times your solute will be given to you in grams, so you have to use the molar mass to go from grams to moles. And then sometimes you'll get your volume in milliliters, which you'll have to convert to liters. Molarity and mole fraction are a measure of a solution's concentration, and molarity is most often used when the solute is a solid and the solvent is a liquid. Alright, put the steps in order for solving molarity concentration problems. First, you want to determine the solute's molar mass. Then you want to convert grams of solute to moles of solute using the molar mass as a conversion factor. Then you want to convert milliliters of solution to liters of solution. And then you want to divide the number of moles of solute by the number of liters of solution, and that'll give you the molarity. Sometimes you'll be able to just pick up at step 4 if you're already in moles and you're already in liters. But these are the steps for if you're starting in grams and your volume is in milliliters. Here's an example of a molarity type of problem. Calculate the molarity of each of the following solutions. So if you have 12.4 grams of potassium chloride in 289.2 milliliters of solution. So you'll want to use those steps that we just talked about to solve this problem. So first, determine the molar mass of KCl by adding up the mass of potassium plus the mass of chlorine. That's the 74.55 grams per mole. Then convert grams of KCl to moles of KCl by dividing by the molar mass that you just calculated right here in step 1. So 12.4 given to you in the problem divided by the 74.55 gives you 0.166 moles. Then you want to convert your milliliters to liters by dividing the milliliters by 1,000. Then you want to divide moles of solute by liters of solution. So 0.166 divided by 0.2892 gives you a molarity of 0.57 moles per liter. Alright, so now we're moving on to discuss mole fraction of a solute in a solution. So we'll go over the general equation for that, and then we'll do 2 practice problems. So what you should do now is write the equation and then try out these problems before I go over it. Okay, so the general equation is that the mole fraction for solute equals moles of solute over total moles of solution. And if you were doing these 2 practice problems right here, you would want to take the moles of, for this one you're actually doing the mole fraction for each compound in each of the following solutions. So for here you want to do the mole fraction of H2SO4 and the mole fraction of H2O. So you just take the number of moles of H2SO4, which is 25.4, divide that by the total moles of solution, which ends up being 275.4. That comes from adding the 25.4 plus the 250. That would be the total moles of solution. The most common mistake I see here is just taking the 25.4 and dividing it by the 250. You can't do that. You have to divide it by the total solution, so you have to add up these 2 numbers. For H2O, you want to take the moles of H2O, which are 250, and divide it by the total moles of solution, which is the 275.4. And these are the values you should get, 0.09, 0.91. And these two should add up to 1, because that would be the total amount of solution. And then here's the solution for letter B. So for potassium bromide, there are 35.7 moles of potassium bromide. Total solution, you add the 35.7 plus the 60.5 to get 96.2. When you divide those two, you get 0.37. To find the mole fraction of water, you want to take the moles of water, which is 60.5, divided by moles of total solution, which is again 96.2. Divide those two numbers and you get 0.63. Alright, so what you want to do now is mark an X next to all of the following that would correctly finish this statement. If the amount of solute dissolved in a solution increases, then the following will occur. So these were those colligative properties that we talked about. So what will happen if you have more solute? So if you add more solute to your solution. So the ones that you'll experience a freezing point depression. That means that your freezing point will lower. Think about why we use salt on the streets in the winter. You'll see a boiling point elevation, so your boiling point will increase, and you'll see a vapor pressure decrease. And then in the images below, the solutions in a range of concentrations are depicted. Assume that the solute and volume of solvent is the same in each. This one is a 5 molar solution, so it has 5 moles of solute per 1 liter of solution. This is 4, 3, 2, and 1. So which of these would have the highest boiling point? Which of these would have the lowest boiling point, highest freezing point, lowest freezing point, highest vapor pressure, and lowest vapor pressure? I'm so sorry, let me fix this. There we go. So the one with the highest solute concentration would have the highest boiling point, would have the lowest freezing point, and would have the lowest vapor pressure. And then the one with the lowest solute concentration, the 1 molar solution, that would have the lowest boiling point, the highest freezing point, and the highest vapor pressure. Alright, what's the technique that separates solutions according to component boiling points? And then rank the following chemicals according to the order in which they would be collected from a distillation apparatus. So distillation is the name of the technique, and remember that it dissolves out the chemicals in order of boiling points. So the lowest boiling point of 64.7 would boil first, then the next lowest, then the 97.2, then the 97.5, and finally the 117. So true or false? Letter A, chromatographic separations utilize a stationary phase and a mobile phase. Chromatography can be used to identify unknown compounds, and many different types of chromatography exist for a variety of different purposes. These are all true statements. And then label the stationary phase. So which of these is the stationary phase? Which of these is the mobile phase? Which is the mixture component that has more affinity for the mobile phase? And which is the mixture component that has more affinity for the stationary phase? D is the stationary phase. That would be the paper and paper chromatography. C is the mobile phase. That's the liquid. A is the one that has more affinity for the mobile phase. It travels further. And then B is going to be the component with more affinity for the stationary phase. It'll be the one that doesn't travel as far. Alright, so if you got most of those right, then you're ready for the test. You guys can come in tomorrow and take the test. You're ready to go. If you missed or had trouble with a lot of those, then you definitely want to study more. Please let me know through K-mail if you need any help with anything. And good luck.